Yes, children, let us see the concept of inverse of a matrix or invertible matrices. See the definition. If A is a square matrix of order M and if there exists another square matrix B of the same order M such that AB is equals to BA is equals to I, that is AB multiplication is equals to B into A multiplication is equals to I, means identity matrix of the same order, then B is called the inverse matrix of A and it is denoted by A inverse. This is read as A inverse and A is said to be invertible matrix. So this is the definition of matrix, inverse of a matrix, that A is a square matrix. This is important condition. One more thing is that it must be a singular, non-singular matrix also. So non-singular matrix, the determinant is not equal to 0. So square matrix of order M and there exists another matrix B of the same order and condition should be satisfied that AB is equals to BA. A into B multiplication as well as B into A multiplication, both are equal to identity matrix. So this in this case B is called as the inverse of A and A is called as the inverse of B, and that inverse of A is denoted by A inverse. Okay, and matrix A is invertible. For example, this is the matrix A, 2 by 2 matrix, 2 3 1 2 elements are, then matrix B, 2 minus 3 minus 1 and 2. We'll find the matrix multiplication, AB multiplication, A into B. This is row into column multiplication. So we get 2 into 2, 4 and 3 into minus 1, minus 3 as the first element. So 4 minus 3, then first row into second column. It will be minus 6 plus 6. Okay, 2 into minus 3 and plus 3 into 2. So minus 6 plus 6. First row, first column, we get the first element. First row into second column, second element. Now there is no row further in the B matrix. So now multiply by the second row of the first matrix to the first column and the second column. So it will be 2 into 1. This is 2 and 2 into minus 1, minus 2. 2 minus 2, third element, and 1 into this minus 3 and plus 4. Okay, so minus 3 plus 4 is the fourth element of this matrix. This matrix is 1 0 0 1. That is identity matrix. So A into B, this multiplication is I. Okay, further find out B into A multiplication in the same way, and that is also identity matrix. So we get the identity matrix again. You try that multiplication and you will get the matrix as identity matrix of the same order too. So this is also equal to I, and hence here B matrix is called the inverse of matrix A. So B is the inverse of matrix A. Okay, that is B is A inverse, that and A is equals to B inverse. And if we replace that B by A inverse, then we get the relation A into A inverse is equals to I. It is nothing but A into A inverse. So if we take the multiplication of inverse of the matrix with matrix A, okay, we get identity matrix. So A into A inverse is equals to identity. Now see how to find the inverse of the matrix by elementary operations. So elementary operations means it can be elementary row operation or elementary column operation. So this example I'm going to solve by elementary row operations. Okay, this is 3 by 3 matrix A, and this matrix is 0 1 2 1 2 3 3 1 1. We have to find its inverse. Okay, so we can write the relation A into A inverse is equals to identity matrix. We know that A into A inverse is identity matrix. This is matrix A. Into A inverse we have to find, and we can substitute on the right hand side identity matrix of the same order of order 3. So A into A inverse is equals to identity matrix I. Okay, now what is the procedure? We will convert this matrix A in identity matrix. So convert this matrix A in identity matrix. Then in that case, it will be A I into A inverse. I into A inverse is equals to whatever the matrix will get on the right hand side will be the inverse matrix, because identity matrix into any matrix becomes A inverse. So we will apply that logic. Okay, that is, we will convert this matrix A into identity matrix. That means we need 1 in this place. That is, in place of A1 1 we need 1. Here we need 1, then here 0, then 0. Okay, so 1 or 0 0 like this. So we will convert this matrix A into identity matrix. The same row transformation whatever we are doing on the left hand side, that we have to do on the right hand side matrix also. So it will get converted, the numbers will get changed, and on the right hand side whatever the matrix will be after complete row transformation, then we get the inverse of the matrix. See the row transformation carefully. Means we can interchange the row, we can multiply elements of any row by any constant, and then we can add the multiples to the another row. So in this way we have to perform the row transformation. See, for example, here there is 0 in the first row. Okay, and in the second row this element is 1. This is the second row, so this element is 1. Now what we will do, we will interchange the row. We want this 1 in this place and 0 should be in this place. Okay, so we will interchange the rows, interchanging the rows. This is R1 and R2, interchanging R1 R2. This symbol is used for interchange. So interchanging R1 R2, we get 1. Means now we have to interchange the rows. The second row I will write on the first row, and first row elements I will write in the second row. Okay, so now this row becomes 1 2 3. This is the first row. Okay, and the second row will be 0 1 2. So I have interchanged the first row and second row elements. First row elements will be the second row elements, second row elements will be the first row elements. Okay, so this is the new matrix. Whatever this row transformation I am doing on the left hand side, I will do the same row transformation on the right hand side also. Okay, so here on right hand side, this first row is 1 0 0. Now I have written 0 1 0 second row elements in the first row and first row elements in the second row. This is interchanging the rows, interchanging first and second row. Okay, understood? So interchanging first and second row, this is the first step. So I get 1 here, 1 is already there. Now here we need 0 and in this place 0. When we are doing row transformation, we should get column wise 1 0 0. So in the first column there should be 1 0 0. Okay, 1 is there. Now 0, we get 0 also. Now in this place we want 0. In this place here, instead of 3 we need 0. Okay, now how 0 will come? We will multiply this 1. Using this 1 we have to make this place as 0. So we will multiply this row by 3. Then it will become 3 here, and these numbers also will get changed, but this will be 3, and then subtract from the third row. Okay, now we are changing the elements of the third row. So I am going to write the third row first. So I will write third row R3. R3 changes to R3 minus 3R1. R3 minus 3R1. So this is R3. R3, this element is 3 minus 3R1. So 3 into the elements of the first row. Element of the third row minus 3 into the element of the first row. Okay, so here I am writing the elements. We will get 3 minus 3 into the element of the first row is 1. Okay, understood? So 3 minus 3 into 1. So this element will become 0. Okay. Now the second element. Second element will be 1 minus 3 into 2. So it will be 1 minus 3 into 2. Okay. That means this is minus 5. Understood? We are changing the element of the third row. Okay. This is R3 changes to R3 minus 3R1. We are changing the element of R3 only. So we will write the first row element, second row element as it is. No need to change the first row. We are not multiplying the elements of the first row. It will remain as it is. It will not get changed. So first row element will remain as it is. We are just subtracting the multiples of the first row from the third row element. So change will be in the third row elements only. And what will be the third element? See, observe this. So this is 1 minus 3 into 3. So 1 minus 3 into 3, we get minus 8. So I have written minus 8 here. Okay, note that the first row element, second row element will remain as it is. We are not changing these elements. We are only changing the elements of the third row. So now the third row becomes 0, minus 5, minus 8 after the row transformation. On the left hand side, the same way we have to calculate on the right hand side. Now we are multiplying this first row by 3 and then we are subtracting that element from the first row. So here there is 0, 0 minus 0, it will become 0. This element will be 0 minus 3 into 1, that is minus 3, and this element 3, 1 into minus 3 into 0, so it will remain 1. Okay, whatever the transformation we are doing on the left hand side, the same transformation we have to do on the right hand side also. Okay, so in this way we get the first column as 1 0 0. So first column becomes 1 0 0. Our target is finished for the first column. So we get the first column. Now we will shift to the second column. Column wise we have to bring 1 0 0 0 1 0 and 0 0 1 on the left hand side matrix. Okay, now here there is already 1. In this place we want 1, so it is there. No need to change. Now we need 0 in place of 2. We need 0 in place of minus 5. Now for this place we need to, now the row transformation, we are going to change the first row. So the row transformation will be R1 minus 2R2. We will use this one to make this element as 0. Okay, so this one, this is a 1. Here we will multiply this one by 2 and then subtract from the first row elements. Okay, so now that row transformation will be R1 changes to R1 minus 2R2. R1 minus 2R2. Okay, so see the elements. This is 1 minus, I'm writing here 1 minus 2 into 0. This is R1 element 1. Okay, R1 element, this is 1 minus 2 into 0. This element will remain as it is. This is 1. Now the elements of R1 only will get changed because we are doing the row transformation on the first row. Similarly, the second elements will be 2 minus 2 into 1. This is 2 minus 2 into 1. Okay, understood? And the third element will be 3 minus 2 into 2. 3 minus 2 into 2. Okay, so it will become minus 1. Okay, minus 1. Here it is, minus 1. So we get the first row element as 1 0 minus 1. 1 0 minus 1. In this way we get 0, and always keep in mind that once you get 1 0 0 here, it should not get changed. Okay, so if it is changing, then your row transformation is wrong. You keep in mind. So 1, and here we get 0 in this place. Okay, now here we want minus, instead of minus 5 we want 0. This is the third row element. Now we have to perform the row transformation on the third row. Oh, sorry, say on second and right hand side also the first row elements will get changed. We are multiplying the second row by 2 and then we are subtracting these elements from the first row. So it will be 0 minus 2 into 1 minus 2. Then 1 minus 2 into 0 is, it will remain 1. This, both elements are 0, it will remain 0. Okay, so the same row transformation R1 changes to R1 minus 2 R2 we have to perform on the right hand side also. Understood? So we get the right hand side as matrix, first row of this matrix minus 2 1 0. The remaining rows will remain as it is. No need to change the remaining rows. Now next step is to bring 0 in this place. In the second column this is 0 1 and here we want 0. So for this 0 we will multiply, again take the help of this one, we will multiply this second row element by 5 and then we will add in the third row. So now we are going to change the third row. So R3 changes to R3 plus 5 R2. R3 changes to R3 plus 5 R2. So multiply all the elements of this row by 5 and add in the third row. So now it will be 0, both are 0, it will remain 0. Then plus 5 minus 5, this becomes 0, plus 5 minus 5 0 and this element will be 10. So 10 minus 8, here I get 2. Understood? The first and second row elements will remain same. Write these elements same. 1 0 minus 1 0 1 2, they will remain same. We are going to change the third row elements only. The third row elements only will get changed. 0 0 2, we get 0 here. Okay, so now the first column becomes 1 0 0, second column becomes 0 1 0. Okay, and the same transformation should be here on the right hand side, as this is R3 plus 5 R2. R3, this is R3 plus 5 R2. So 5 into 1 plus 0. So we get 5. Here 5 into 0 is 0 minus 3 minus 3. And then 5 into 0 is again 0 plus 1 1. Okay, this is the third row on the right hand side. Okay, so third row on the right hand side. So now we get the first column as well as second column. Now we want 0 0 and 1 in this the third column. So first of all try to get 1 and then we will get 0 using that one. So here to get 1, the simple way is divide this third row by 2. So I'm going to divide the third row elements by 2. R3 changes to R3 divided by 2. So R3 divided by 2, these are third row elements. These two are zeros, 0 by 2, it will remain 0 and 2 by 2, 1. So here I have written 1. Understood? So I get 1 here. Same procedure I have to do on the right hand side matrix also. It will become 5 by 2 minus 3 by 2 and 1 by 2. Okay, so we have divided the third row by 2. So now these are the elements 0 0 1 on left hand side, 5 by 2 minus 3 by 2 1 by 2 on right hand side. These two rows will remain as it is. Okay, and using this one we need 0 in these two places. Okay, so in the third column now we need 0 here, here 0. Okay, instead of minus 1 and 2. For this is the element of the first row. So I have to do R1 changes to, this is minus 1, this is plus 1. Just add them, we will get 0. Minus 1 plus 1 becomes 0. So R1 plus R3. The row transformation will be R1 plus R3. Okay, and this is 2. So 2 minus 2 will be 0. So for this element, this is the element of the second row. So I have to perform R2 changes to R2 minus 2R3. R2 minus 2R3. Okay, so we will multiply this 1 by 2 and then subtract the corresponding elements. Okay, and now I think you have understood how to perform this row transformation. After this two, we can do the two row transformation at the same time because we are using R3 only in these two. So R1 changes to R1 plus R3. You will get R1 plus R3, 1 plus 0, 1, 0 plus 0, 1, 0 and minus 1 plus 1 becomes 0. Okay, so here in the first row 1 0 0. Okay, and in the second row 0 plus 0 minus 2 into 0, this will remain 0. 1 minus 2 into 0, it will remain 1. 2 minus 2 into 1, so it will become 0. So we get 0 1 0 here. The same row transformation you have to perform. Now be careful because these numbers are in fraction. Here on the right hand side it will be minus 2 plus 5 by 2, and minus 2 plus 5 by 2 becomes minus 4 plus 5 by 2, it will become 1 by 2. Then 1 minus 3 by 2, 1 minus 3 by 2. So perform these calculations carefully. 1 minus 3 by 2, it will become minus 1 by 2, and this is 0 plus 1 by 2, it will become 1 by 2. So when it is in fraction, be careful in addition or subtraction of the fractions. Okay, so 1 by 2 minus 1 by 2, 1 by 2. Okay, and the same way perform the second row transformation. R2 changes to R2 minus 2 R3. We get the numbers minus 4 3 minus 1, and the third row elements will remain as it is. So now we get the identity matrix I on the left hand side. So this is nothing but I into A inverse is the A inverse matrix. So this is the whatever the matrix on the right hand side, this will be the inverse of the matrix. So A inverse is nothing but this matrix. 1 by 2 minus 1 by 2, 1 by 2, minus 4 3 minus 1, second row. 5 by 2 minus 3 by 2, 1 by 2 is the third row. So this matrix is the inverse of matrix A. So it is denoted as A inverse. So A inverse is this matrix. So in this way we can find inverse of the matrix using elementary row transformation. Once we get 1 0 0 or 0 1 0 on the left hand side, they should not get change. Okay, so we can use the elementary row transformation or elementary column transformation also. So when we use elementary column transformation, we will get 1 0 0 row wise. We will bring 1 0 0 row wise on the left hand side. Okay.